Hello viewers, welcome to Senior College Mathematics. In this series of teachings, we have College Trigonometry. Lesson 12, Selected Problems, Part 4. You have example 52. Show that cos 2a minus 1 over cos 2a plus 1 is equal to minus tan squared a. Solution. From the given problem, you can replace the double angle of 2a with this and this respectively. If you add these two terms, you have minus 2, and minus 1 plus 1 is 0. You are left with 2 cos squared a in the denominator. From here, you can factor out 2 from the numerator. You have it in this form, and that 2 will simply replace this 2, and you have this result. We are aiming at this. To get this term will remain because tangent is the ratio of sine to cosine. So we need to transform the numerator to sine squared a so that we can get the required result. Recall that sine squared a plus cos squared a is equal to 1. And this place is negative. So what we actually need is minus sine squared theta. So this is what happened. You transfer this term to the right, it becomes negative. You transfer 1 to the left, it also becomes negative. So we can replace this with this. So you come back to this place. That is what you have here. It becomes minus sine squared a over cos squared a, and that is minus tan squared a. Therefore, the given identity is true. Example 53a. If s and y are acute angles such that sin s is equal to 4 over 5 and cos y is equal to 12 over 13. Calculate without using tables. Roman figure 1, sin s minus y. Roman figure 2, cos s plus y. Also show that cos s plus 30 degrees plus sine bracket open s plus 60 degrees is equal to 3 over 5 bracket open 1 plus root 3. Then B part of that question, show that sine 2a over 1 plus cos 2a is equal to tan a. Solution. Let's take A, Roman figure 1. Sine s minus y is equal to this from compound angle. From sine s equal to 4 over 5, you need to get cos s. We need sine y and cos s, so we start with cos s using the information about sine y. You do that by drawing a right-angled triangle. From sine, this is the acute angle, 4 is the opposite, 5 is hypotenuse. By Pythagoras rule, the adjacent is 3. It follows that cos s is 3 over 5. Next, we get sine y with the information about cos y by also drawing a right-angled triangle. This is the acute angle y. 12 is adjacent, 13 is hypotenuse. By Pythagoras rule, the opposite is 5. Therefore, sine y becomes 5/12. Let's go back to what you were asked to look for, which is this. You simply replace cos s, sine s, cos y, sine y with what they stand for. You have this expression. When you multiply, you have this. You find the LCM because it is fractions subtraction. When you simplify, you have 33/65. Roman figure 2 of part A is the cosine of s plus y. That is compound angle. And you have this expression. Already, you know what cos s, cos y, sin s, sin y stand for previously. You simply replace them and you have this result. After subtraction, you find the LCM and you have 16/65. We are also asked to show that this expression is equal to this. Before taking the whole expression, this is compound angle, this is also compound angle. You have to take them respectively. So if you take the first one by compound angle formula, you have this result. In the question, cos s is 3/5. Cos 30 degrees is √3/2 minus sin s is 4/5 and sin 30 degrees 1/2. When you simplify, you have this result. We take the second compound angle in the expression, which is this, and you have this result. From the question, sin s is 4/5 times cos 60 degrees 1/2 plus cos s 3/5 times sin 60 degrees √3/2. When you simplify, you have this result. Now we consider the whole expression. Cos s is 3/5 plus the value for this compound angle, which is this, it follows, plus the value for this compound angle, which is this, it also follows. From here, we add like terms first. 3/5 is going to be there. Now consider this and this like fractions. When you add first, okay, we take them together. Then minus this plus this is 0. From here, 3/5 is outside, and from the remaining terms, you can factor out 3/5. If you factor out 3/5 from the first term, you have 1 remaining. You factor out this 3, you are left with √3. You factor out 5 from 10, you have 2 respectively. You see that? Next, you have 3/5 bracket open 1 plus. If you add these two terms, because they are like fractions, you are going to have 2 √3/2, and that is √3. Therefore, you have 3/5 bracket open 1 plus 3 √3. 1 plus √3. 1 plus √3. Part B of that question showed that sin 2a over 1 plus cos 2a is equal to tan a. In this part, the complex side is the left. You start from that side and simplify it to get the right hand side. This is a compound angle, same as cos 2a. You replace them with what they stand for previously. You have this result. From here, we can replace 1 minus sine squared a with cos squared a. So we write both together so that this expression here is equal to this from identities. The numerator remains the same. Now, when you add these two terms, you have this result. 2 cancel 2. From here, you can express this as cos a times cos a because of power 2, so that 1 will remove 1 from here. You are left with sine a over cos a, and this ratio is always equal to tangent, that is tan a. Therefore, the identity is true. Example 54, if tan theta is equal to 5 over 12, where theta is an acute angle, evaluate sin theta over sine squared theta plus cos theta. Solution. In order to evaluate this problem, we need hypotenuse. It is needed in order to get sine and cosine, and you obtain it using the information about tangent by drawing a right angled triangle with theta as the acute angle. 5 is opposite, 12 is adjacent. By Pythagoras rule, the hypotenuse is 13. Therefore, sin theta is 5 over 13, cos theta is 12 over 13. You come to this place, this is the value of sin theta. You come here and you square the same value. You add the one of cos theta to it. When you simplify, you have this result. The denominator, if you find the LCM and simplify, you have 50 over 169. Now, you divide numerator by denominator, you change the visual sign to multiplication, and you invert this fraction to 169 over 50. When you reduce 5 and 50 by 5, you have 1 and 10. You reduce this and 13 by 13, you have 13 in the numerator. Your final answer becomes 13 over 10. Example 55a, show that 1 plus 2 cos theta is a factor of f of theta equal to 8 cos cube theta minus 4 cos theta minus 1. If theta is equal to 36 degrees, the solution of f of theta equal to 0 show that cos 36 degrees is equal to 1 over 4, bracket open, root 5 plus 1, bracket close. B part of the question. In a triangle PQRO, QRO is equal to 7 cm, angle PQRO is 120 degrees. If the area of the triangle is 14 root 3 square centimeters, calculate the remaining sides of the triangle. A part of the question. What you have here is a polynomial in trig ratio. This term can only be a factor if you divide the polynomial by this factor and the remainder is 0. So you have f of theta equal to this. We draw the division box. What you are dividing is inside the box. What is dividing it is outside. Here it is 2 cos theta that we divide. So you divide 8 cos cube theta by 2 cos theta. You have 4 cos squared theta. The process is division, multiplication, and subtraction at each stage. So you use this first result to multiply this factor and you have this. Next thing is to subtract. When you subtract 8 cos cube theta minus 8 cos cube theta is 0. This place becomes negative, and because no other term you can subtract it from, you bring it down. The next term, minus 4 cos theta, you bring it down also before you divide again. You divide the first term by 2 cos theta, you have minus 2 cos theta. Here, the first term here, you divide it by this term, you have this result. Next thing is to multiply. You use minus 2 cos theta to multiply everything here, you have this result. Next thing is to subtract again. So minus this minus this is 0. The effect of the minus sign we make here to be plus. So you have minus 4 cos theta plus 2 cos theta, and that is minus 2 cos theta. The last term, minus 1, you bring it down. Again, you divide the first term by this term and you have minus 1. When minus 1 multiply everything, you have this, and when you subtract, you have 0. Therefore, 1 plus 2 cos theta is a factor of this polynomial. Since the remainder is 0, it shows that 1 plus 2 cos theta is a factor of f of theta. So therefore, the given polynomial is equal to the product of the divisor and the quotient. Next, we are told that f of theta is equal to 0. This statement implies that what you have here, you equate it to 0, and you equate each factor to 0. Let's take the first one. 1 plus 2 cos theta equal to 0. This one cannot give us the required form. You are asked to show that cos 36 degrees is equal to 1 over 4 bracket open root 5 plus 1. We cannot get that from here, so let us consider this. This is quadratic in nature, and let us recall the quadratic formula. From here, the coefficient of cos squared theta is a, and that is 4. The coefficient of cos theta is b, that is minus 2, and the constant term is minus 1. You have them in the formula. When you simplify, you have these results and this result. If you express this in basic form, it becomes root 4 times 5, and root 4 is 2. So you have 2 plus minus 2 root 5 over 8. You can factor out 2 from here. You have it in this form. You can divide 2 and 4 by 8. You have this result. This plus minus means you can write the expression twice in this form. So when theta is equal to 36 degrees, this cos theta that is equal to this becomes cos 36 degrees equal to this or this. For the required form, we take cos 36 degrees equal to root 5 plus 1 over 4. If you factor out 1 over 4 in this form, you have it multiplying root 5 plus 1. Part B of that problem, what you have here is the best diagram that can be produced based on the information in the question. But finding the remaining sides is not possible the way the diagram is appearing. If you are to go by sine rule, this side you need the angle. If you are to go by cosine rule, you need at least 2 sides, and any of these is not possible. So the diagram is adjusted to this form. So if this angle is 120 degrees and this is a right angle triangle 90 degrees, the remaining side is 30 degrees, so that we can find the other sides. From this adjustment, triangles PQS and ROQS are right-angled triangles. The height is needed first, then proceed to find arrow side PQ, and finally you find Q, that is side P arrow. Arrow is side PQ, then Q is side P arrow. Area of triangle ROQS is 1 over 2 times base times height, and that area is given as 14 root 3 equal to half is 1 over 2 times the base 7 times height unknown. You have it in this form. When you cross multiply, you make h the subject, you have it in this form, and 4 root 3 centimeters. Considering triangle PQS tan 30 degrees is equal to opposite over adjacent, and that is s over 4 root 3. In this triangle now, this is the acute angle. You have this as hypotenuse, this is opposite, and the height is adjacent. From special angles, tan 30 degrees is equivalent to 1 over root 3 equal to s over 4 root 3. If you cross multiply, you have this result. Divide through by root 3, s is equal to 4 centimeters. By Pythagoras rule again, we want to get arrow now in triangle PQS. Arrow is the hypotenuse. You state the Pythagoras rule in this form. S is equal to 4. Hence, you have 4 squared. H is equal to 4 root 3. You also square it. And you have arrow squared to be equal to 16 plus 4 squared is 16 times root 3 squared is 3. And you have arrow squared to be equal to 16 plus 48. Arrow squared is equal to 64. To get arrow, check the square roots of both sides, and arrow is equal to 8 cm. Therefore, PQ is equal to 8 cm. To find Q, which is side P arrow, you need to consider the whole triangle PQ arrow. Now, you know this to be 8, this is 7, the whole of this angle is 120. You can use cosine rule. The cosine rule stated in terms of Q, the unknown side is this. You replace P arrow and angle Q with what they stand for, you have it in this form. When you simplify, you have this result and this result, and finally 169. To get Q, you take the square root of both sides, and Q is equal to square root of 169, and that is 13 centimeters. Therefore, side P arrow is equal to 13 cm. End of lesson 12. Thanks for watching and learning. Don't forget, watch out for more from the voice of Peter Kos. Lastly, if you are not safe, your life is in crisis. To avoid that, give your life to the Lord Jesus Christ and confess Him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be left. Take good care of yourself. Stay out of trouble. Study your books. Do the needful at all times. Flee every appearance of evil. Don't defraud others to make money. Find something good to do with your hands and your brain, and the Lord will bless you. Goodbye and stay tuned.